Welcome. In this table, which is labeled as 5.3, we compare one last time simple interest and compound interest and the progression of amount accumulating simple interest and amount accumulating compound interest, which we denote as future value with simple interest, which is in this column here, and future value with compound interest, which is shown here. Now, in the previous illustrations connected with this one, we've talked about not only the final value, but also about the interest accumulated. So we're going to bring it all together in this little table here. What is the interest accumulated with simple interest and the future value that is accrued after a combination of that simple interest with the present value, as well as compound interest accrued and the future value obtained after combining the compound interest and the starting value. So let's get into it. So this is going to be $100 at all times for present value with simple interest, and the interest accumulated in the 0th period is NA, because we haven't really gone any forward. So the future value is going to be NA, we can say, because it's $100 or just 100. And same applies actually for the compound interest treatment as well. Now, moving on. So why don't we do this? Let's just give it a gray shade or something like that. Maybe just give it a little light blue shade for simple interest. And then let's give it a little light, I don't know, green maybe for compound interest. And let's make the time column just gray, boring gray. Yeah. And then how do we put some grid lines on this table? Alt OE, B, Alt OI, enter in a Windows computer. Now equals this. So again, this is time, this is present value, starting value, at the end of first period, end of second, or beginning of first period, beginning of second period, beginning of third period, beginning of fourth period, and beginning of fifth period. It's not going to be the same in the case of compound interest. So for the sake of fun, let's just Alt O, E, A, Alt M, enter, and Control Y. And so let's take the color combination, Alt EST, enter. Oh my God. Okay, let's try it again. Alt EST, enter. Alt O, E, A, Alt M, enter, and then Control Y. Okay, so we will just give it a title, simple interest method. So when the interest calculation is by simple interest, compound interest method. Okay, so the simple interest so calculated is a left arrow times $AU$1. And it's going to happen across all the periods. The only thing is the future value is going to be this plus previous. So it's going to become 110. But wait a minute, the present value which is used to accrue the interest will go back or reset itself to 100, even though we have $10 in our hand. And so we keep on adding that to grow this amount or the future value with time. So it becomes 110, 120, 130, 140, and so simple interest. That's a concept of simple interest. But with compound interest, this is the present value which will grow, interest will accrue and keep getting added to the future, into a future value. So we will do the same thing. First of all, equals left arrow, equals left arrow, sorry, equals right arrow, equals, this one is equal to left arrow times $AU$1. Now the future value, as is in the case of simple interest, is these two, sum of 100 and 10, the principal and the interest. But now the next period starting value will no longer get itself reset. It will continue from the previous period's ending value, and this is the most common and popular way of calculating interest, whether it's mortgages, credit cards, any kind of loans or deposits, unless otherwise mentioned. And so all we do is Control D, Control D. Notice how the incremental interest made the interest accrued grow. And so now the starting value is 121 and it ends at 133.1. Now The starting value is 133.1, ends at 146.1. Starting value is 146.1, ends at 161.051. So this is how we have actually constructed this table here. So the future value in simple interest climbs up to 150, with compound interest climbs up to 161.05. Now we can actually go ahead and prepare a graph, and this graph will have time on the x-axis and the future values respectively for simple interest and compound interest on the y-axis. And so we choose that. Okay, and let's just remove that. Now let's, for the sake of fun, start with 100, because, or let's just make it 80 maybe. So we can see how the two start diverging. Simple interest is this blue line, and compound interest is that orange line. So with time, as compound interest picks up more and more interest, it starts growing faster. In fact, it grows exponentially fast because of that exponent on top of 1 plus r. And so that is the discussion of simple and compound interest. Thank you for listening. Now let's look at the interest earned through simple and compound interest in a separate chart. So going back to the same discussion, all we need to do now, so we just calculated or plotted the amounts. Now we're going to plot the interest accrued. So interest always accrued in every period is $10 for simple interest, but it keeps growing with time for compound interest. So that we'll see here, and just removing that. So with respect to simple interest, it's just a straight line, $10. And then with compound interest, that interest keeps on growing with time. And that is figure 5.3 that we see here. 5.2, I apologize, on the accrual of simple versus compound interest. Thank you for listening.